Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to talk about how to graph and write linear functions. So this lesson will have a big parallel to a lesson from Unit 5 where we learned how to graph and write linear equations. Remember, linear functions and linear equations are virtually the same, right, except we use function notation. So instead of writing y, right, we now use f of x or g of x or h of x. So if we think about these functions just like we would linear equations, this lesson will be quite a bit of review. So we have a function here, f of x is equal to 3x minus 2, and we're asked to graph it. There's a graph down below, you just can't see it on my screen yet. Before you do that though, I'd answer questions 1 and 2. That may put you on the right track as far as how you're going to graph this function if the f of x, again, is throwing you off a little bit. So pause the video, answer questions 1 and 2, try to graph the function, and then go back and answer question 3. Okay, I'm going to scroll down here a little bit, I think. I guess we can answer question 1 first. Question 1 says, what type of form does this function appear to be written in? Think back to Unit 5 and the types of linear equations we looked at. Well, we had 3 types of linear equations, right? We had slope-intercept form, which was y equals mx plus b. We had point-slope form. So we had y minus y1 is equal to m times the quantity x minus x1. And finally, we had standard form. Less commonly used, but ax plus by is equal to c. So this function over here, right, seems to be in slope-intercept form. Again, the only difference is that this y is being replaced with f of x. So we should be able to pick out the y-intercept and the slope, which is what question number 2 asks. What do we need to identify to help us graph the function? Well, we need the slope and the y-intercept. Slope being 3, y-intercept being negative 2. So let's go ahead and graph. I'll rewrite the function just so we remember what it is. F of x is equal to 3x minus 2. Y-intercept is negative 2, so I'll plot that. This graph does count off by units, so I can just count my change in y, which is 3. My change in x is just 1, so my new point would be right here. Let's do that a little bit better. And I can draw my line between the 2 points. So this line would represent this function, f of x is equal to 3x minus 2. Again, the only difference in this function versus a linear equation is that we replace the y with the f of x. So let's say you didn't put 2 and 2 together that this function was in slope-intercept form. So you didn't know what the slope was, you didn't identify the y-intercept, but you still were asked to graph it. Well, if we think back to last lesson, there's a way for us to come up with ordered pairs or points for a function, right? We can pick an input, substitute it into the function, and get an output. So let's start with our original function, f of x is equal to 3x minus 2, and let's choose an input at x equals 1. So when x is equal to 1, I get f of 1 is equal to 3 times 1 minus 2. Remember, if x is equal to 1, I replace all of my x's with 1s. So I get f of 1 is equal to 1. 3 minus 2 is 1. So my input was 1. My output was also 1. So my point ends up being 1, comma 1. And you'll notice that was already a point we had on our line. Okay, so we could have chosen that point. If I choose another input, let's do at x is equal to, let's do a negative number. Let's do -2. So I have f of -2 is equal to 3 times -2 minus 2. I get f of -2 is equal to -6 minus 2. And I get f of -2 is equal to -8. So my input was -2. Remember, inputs are my x values. My output, my y value, is going to be -8. So my point was -2, comma -8. Now, this is going to be a little bit off the graph. And you can see that my line actually isn't drawn great in this scenario. Let's draw this a little bit better. Because this point right here, -2, -8, should also be another point on my line. Well, that's also poor. Something like that. But that being said, this would be another way of coming up with 2 points on your line. And if you come up with 2 points, you can draw a line between those points. So even if you're unable to identify the slope and the y-intercept, you can choose 2 input values, 2 x values, figure out what y values go along with those x values, or figure out what outputs go along with those inputs, and then that will give you 2 points, 2 sets of ordered pairs, and that will allow you to graph your line as well. Sometimes it's not easy to put an equation or a function in slope-intercept form. So this method may be an easier way for you to find 2 points on your graph. All right, let's move along to the next page. We're going to skip number 4 because that's basically the same thing we just did. This function's already in slope-intercept form, so you could identify the slope and the y-intercept. We will have you go through number 5, though, because this function is not in slope-intercept form. So you have a couple different ways of trying to figure out your points. Maybe you want to rearrange it into slope-intercept form. Maybe you want to just choose 2 inputs and figure out the outputs and graph those points. Pause the video, take a few minutes, see if you can graph the function, and then join us back for a discussion. Okay, so we'll do this in a couple different ways, just because I don't know exactly which way you attempted it. The first thing we'll do is try to put this into slope-intercept form. So let's start with what we're given. G of x is equal to 2 times the quantity x minus 1 minus 8. I'll distribute that 2. So I'll get g of x is equal to 2x minus 2 minus 8. And that will give me g of x is equal to 2x minus 10. So this pretty clearly gives me my slope and my y-intercept. It's already in slope-intercept form. My y-intercept is -10, so I can plot that point. And we'll go ahead and write down the coordinates here as well. The problem here is that this graph is not ticked off by units, right? The x and the y-axis is split up by 5s, not by 1s. So we're not going to count the change in y and the change in x. We're going to need another method. We've done this before, though. We've graphed equations that were not on a graph that was ticked off by units. We've worked with graphs with many different types of axes. So we have an idea of what we need to do. We just need to find some other point, plot it, and then draw the line between the 2 points. We're going to do what we did above. I'm just going to choose an input. Okay, so I'm going to start with my original. And I'm going to choose x is equal to 2. So I get g of 2 is equal to 2 times 2 minus 10. I get g of 2 is equal to 4 minus 10. And I get g of 2 is equal to negative 6. This represents my y value, or my output. My input was 2. My x value is 2. And I should be able to plot, right? My point now becomes 2 comma negative 6. So again, you're not going to know exactly where that point is, but we're just going to label it as 2 comma negative 6, so we'll be okay. 2 falls about right there. Negative 6 falls about right there. So our point should be somewhere right there. And as long as you label it 2 comma negative 6, you're fine. That will be acceptable. I'm going to draw my line between the 2 points. Again, you could have chose some other number. Let's choose 6 and see how close that point is to our line. So if I do at x is equal to 6, I get g of 6 is equal to 2 times 6 minus 10. G of 6 is equal to 12 minus 10. G of 6 is equal to 2. So my point becomes 6 comma 2, right? Up here, my input. Down here, my output. So 6 comma 2, and again, you can tell that I just didn't draw this line super well. Let's try this again, though. Probably looks something more like that. And then if I go over to 6, up to 2, we should see that that point is very close to where our line is. Again, if you're using a straight edge, the better you plot your points, the closer you plot your points to where they're actually at, the more accurate your line's going to be. But as long as you have your points labeled, that will earn you full credit. So just make sure you label your points, and then your line doesn't have to be perfect. Okay, let's see what's next. Probably going to be moving on to some tables. Now we're going to go the opposite way. We're going to, instead of graphing functions, we're going to write the equation of the function. So we have some tables here, and it says write a function f of x that describes the relationship between the x and y in the tables below. Think back to how we did this in Unit 5. The process is the same. You will just replace your y with f of x when you have your final equation. You'll notice that our table gives us x and y values, not x and f of x values, but we know that y and f of x mean the same thing, right? They're both our outputs. So we can treat the y's as f of x values, and it does say write a function. So at the very end, right, after we've written the equation of the line, we can just replace the y with f of x, and it'll be in function notation. If we think back to Unit 5, which form of a line, which general equation did we start with when we were building our own equations? Well, we started with point-slope form. Y minus y1 is equal to m times the quantity x minus x1. And we needed to figure out the slope as well as an x1 and a y1. Well, the x1, the y1, right, we can just pick any point from this table. I'll just pick 2, 13. So we can substitute those in right away. Y minus 13 is equal to some slope times x minus 2. Now we need to figure out what that slope is. And to do that, well, we have a formula, right? We have the slope formula. Change in y over change in x we know that's equal to y2 minus y1 all over x2 minus x1. So we need to pick another point from our table to use. We can use 4, 26. We'll stay away from the decimals, make it a little bit easier on ourselves. So that's going to give me 26 minus 13 all over 4 minus 2, which gives me 13 over 2. I can either use 13 over 2, or I could use 6.5. I can use the decimal because it's terminating, it doesn't repeat, I don't have to do any rounding. And I will go ahead and just use the decimal here. Now I'm going to get the y by itself. So I'm going to distribute first. So I'm going to get y minus 13 is equal to 6.5x minus 13. I'm then going to add 13 to both sides. And that's going to give me y. These 13 simplify, the negative and the positive, 6.5x, and the negative and the positive 13 simplify over there. So that's the equation of the line given by the table. Now it says to write a function, so we just need to put this in function notation. All I'm going to do is replace the y, right? Because I know the y and the f of x mean the same thing. So I have f of x is equal to 6.5x. And this would be the function notation that they're looking for. But you notice that the process was exactly the same as what we did in Unit 5. The only extra step came at the end when we replaced the y with the f of x. So you can go ahead. There's a bunch of other problems here to work with. You've got part B. I believe you have 4 more down here as well. So process is the same. In some of these, they already start out with. Let's just take a look at C, for instance, right? They give you the f of x values, but we know that those also represent y values. So if you're more comfortable working with y's to start, well, just call those values y. And at the very end, replace the y with the f of x, right? Same thing over here. These are also our y values or our output values. So you can always treat the outputs as y's until your final answer, if they want you to write your final answer as a function, which they do here. So you'd want to have, f of x or g of x in your final answer rather than y's. But up until your final answer, you can just treat those as y's because y and f of x or y and g of x mean the same thing. They both represent our outputs. Okay, that's going to do it for this video. As always, I hope you enjoy the rest of your day, and we will look forward to seeing you next time.